These flowers sure are the bee's knees. I sure could put cologne that smell like these flowers, but obviously I can't survive like these flowers. Because flowers are plants, and plants make their own food while I'm an animal, and I have to look for my own food. What's up, young Padawans? It's Mr. Marambo coming at you with more science today. Today we have two things on our schedule. First, we'll go ahead and review resource needs of both plants and animals, which I could already say that we successfully completed. And next, we're going to go ahead and dive in on controlled experiments. Today's objective is to identify parts of a controlled experiment to prepare for a virtual investigation on plant resource needs. To foreshadow, you will engage in your own simulation, virtual simulation like we've done in the past, investigating how plants use their resources in order to survive. To get us started on our investigation online, today's goal is to absorb all the information in this reading that I'm going to show you right now on my screen, and also that you will have to complete for today's assignment. As you can guess from the title, it's all about designing an investigation. And for this simulation, you'll be designing your own investigation, which is why it's crucially important for you to know this reading and its knowledge like the back of your own hand. So controlled experiments, what are they? Controlled experiments are what we've been doing in our experiments so far in order to prove or disprove our hypotheses. I'm calling them controlled experiments now because that's what they're technically called. And I'm going to introduce or reintroduce some terminology so that we can incorporate them in this example that I'm going to do right now, and you will incorporate this into your simulation. So in this investigation or controlled experiment, I want to find out how water affects the growth of these roses. As always, experiments, or what we call controlled experiments, always begin with curiosity and a question. This question is, how does water affect plant growth, specifically rose growth? As per routine, I first create my prediction. So if I keep adding more water, then the plant will grow more. So this is my hypothesis written out. If I increase the amount of water, then the roses will increase in how long they are. Then I need to figure out both my independent variables and dependent variables. Now the IV and the DV is something we absolutely should know already, but let's review them just in case. The independent variable is the thing that changes on purpose or does the effect. In this case, since I'm measuring plant growth, let's say in centimeters, what's affecting the plant growing? And the answer is the water. The amount of water is my independent variable. And let's make that in milliliters. Your DV is what's being measured or what's being affected. In this case, I already said it already. What's being measured is how much the plant grows or doesn't grow. We don't know what happens, but that's what we're measuring. To recap my independent and dependent variables, my IV is the amount of water I put into the plant, and the dependent variable is the amount the plant grows. Milliliters and centimeters, what is being changed on purpose and what is being measured. Once we've identified the independent and dependent variables, it's super important to next identify the control variable. And I'm not going to write it down, but the control variables are the things that stay the same. And what stays the same is everything else except for the independent and dependent variable. The control variables is everything else. This includes the amount of sun that they're getting, it's all the same. The type of cup that they're in, it's the same. Control means the same. You're not changing it, you're not touching it. The only thing you're changing is the independent variable, which affects the dependent variable. And that relationship is super important. You input with the independent variable, and then you output with the dependent variable. You make an intentional, a purposeful, you do it on purpose, the change, which is the water in this case, and then you measure whatever happens. Everything else around that, like I said, the sunlight, the type of cup, the type of water, the height of the plants at the beginning, these are all cut at the same height. Those are all controls and must be the same. These are control variables because they help us pinpoint what exactly we want to test. So if my hypothesis is if I change the amount of water, so I increase the amount of water, then the plants will grow more, then obviously the only thing I want to change is the amount of water in the cups. I don't want to change the type of cup. I don't want to change the type of plant. I don't want to change the height of the plant at the beginning. Don't want to change the amount of sunlight because that is not what I'm testing. So in short, the control variables help me make sure that I know what I'm testing. So the control variables help me figure out the relationship between the IV and the DV, whether or not that if I do increase the amount of water, it will increase in plant growth. Step number 3 is to identify my experimental group and identify my control group. And this is really simple and where your creativity comes in. So the experimental group is the group in which I am changing the independent variable. So these in the background will be the cups or the plants, the roses that I will be testing on. So their levels of water will be different. On the other hand, this cup, this rose in the front will be my control group. And what I mean by control group, I will not affect the independent variable in this cup. It is not being tested. It will simply stay as it is. So I identified my experimental group. These 4 on the back have different amounts of water. The one in the middle, my control group, has an equal amount of water, which is half, 50 milliliters. This has 30, this has 10, this has 70, and this has 90. So, experimental group, control group. After I identified what I'm going to experiment with and what's going to stay as the control, so I'm not going to affect the amount of water in it, I then create my procedures on how exactly I'm going to test my hypothesis out. I should, as a good scientist, make my own data table, but in this video, I'm not going to create a data table. But make sure you always have a data table where you record your data down. I wrote my procedures down here. I'm going to measure each day at 8 a.m. the growth of each plant 1, 2, 3, and 4. Not the control group, just 1, 2, 3, and 4. I'm going to measure it again in centimeters on my data table. In my procedures, I said that I'm going to measure it for 4 weeks. 4 weeks every single day collecting my data. And when I'm collecting my data, I'll finally start getting the evidence I need to either support or refute, which means deny my hypothesis, which again was if I increase the amount of water, so this is 10, 30, 70, 90, then the plants will keep growing. So I expect this rose to be the tallest plant by the end of 4 weeks based on my data. And because everything else is controlled, the amount of water that I left in here, the cups, the amount of sunlight they get, their position, everything, then I'll make sure for certain that I can test my hypothesis and see if that relationship between the independent variable, the amount of water I put in the cups, and the dependent variable, how much they grow, is true or not. And there you have it, a rundown on a controlled experiment. There are many steps in making a controlled experiment, which is why we will keep doing this again and again so that we know how to do it like a back of our hand.